Continuing our discussion on associative containers in STL, today we will see unordered set. So far we have seen normal set and multi-set, and both of these were implemented using balanced binary search trees. So all the operations were of logarithmic time. Here it's constant time because these are implemented using hash tables. So if you have not watched these two lessons, then I would highly recommend that first you understand the concepts here and then come here. So let's begin. So it's an associative container that contains a set of unique elements of type key. So this is similar to set, which also allows only unique keys, and this is different from multi-set, which allowed multiple occurrences of the same key. And here you need to include unordered set header. And in these two, set and multi-set, we were including set. Then here everything is constant time. It may not be exactly constant time. That will depend on how good hash function you have defined. And it's implemented as hash table. So this is the default template. So you can see key. This is the type of data that we will store. Then we have a hash. So this is the default std hash. So if you are using unordered set of some primitive types like int, float, string, these things, then you can use the std hash, or if you like, you can provide your own hash function. But if you are storing a custom class that you have defined, then you will need to provide a custom hash function for this, because this C++ will not know how to do the hash of objects belonging to this class. But if you are using some ready-made types, then you don't need to do any of these. So we will see example of this also when we will try to create unordered set of our student class, the same example that we had seen in earlier lessons. And then this is another key equal function that checks for equality of keys. Then this is the standard allocator. Now let's see some of the functions of unordered set. So this should be very familiar to you if you have been watching all the lessons. Size will give you number of elements in the unordered set. This operator equal to is used to assign values to it. Clear will clear all the elements from this, remove all the elements. Count will return either 0 or 1. So in the case of set also, it returns 0 and 1 depending on whether the key is present or not. In the case of multi-set, it will return the actual count of that key. Find, again, if the key is found, it will return iterator to that. If it's not present in the set, it will return that set dot end, which is not pointing to any of the elements of the set. Empty checks whether there are any elements or not. Then we have different versions of insert and erase, which we will see in detail. Then a few of these functions which are additional, which we had not seen earlier, because these are specific to hash table implementations. And there are many more of these. I have just written a couple of them. These functions you generally not use, but if you are interested, you can explore these and a few more of these. We will also try to see examples of at least 2 of these, and we will try to print the number of buckets and the load factor of that table. So let's see insert and erase in detail, which is very similar to what we had seen in set and multi-set. So one way to insert is to insert a key. So you pass the actual value. Like we have a set, unordered set US of ints, and we want to insert 5 into it. So we pass the actual key. So if it's not present, it will be inserted, and then it will return a pair consisting of iterator to this newly inserted element, and also a boolean denoting whether insertion took place or not, true or false. If it's already present, it will not insert it again. So this iterator will again be pointing to this 5 only, and in this case it will return false. Next way to insert it, you pass 2 iterator positions. Let's say we have a vector, we have many elements, and we want to insert from here to here everything in this range to the unordered set. Then we will pass this iterator, position 1, here, beginning of this, and position 2 at the end of this. So position 2 will actually not be inserted before that. So everything here will be inserted into the unordered set. and it does not return anything. Then another way is to insert using initializer list. For example, us.insert, and we pass initializer list 5, 10, 15, 20, and it will insert all the values if they are not present. If they are present, it will not insert that, and it also does not return anything. Next, erase. If you know the position, iterator position of a given element, you can pass that and it will erase that from the set, and it will return iterator following the last element that was removed. So iterator which follows that element that we removed. Then if we want to delete in a given range, we have two iterator position, we can pass that. Again, position 2 will not be removed, position 1 will be removed, and again it returns the iterator following the last element that was removed. And third way is that you don't know the iterator position, but you know the key that you want to remove. Let's say you want to remove key 10 if it's present. So if it's present, it will find it and also remove it, and it will return the number of elements removed. So in this case, unordered set, it's not a multi-set, so it will return 0 or 1 depending on whether it was present or not. In the case of multi-set, it actually returns the number of elements removed. So now let's see this in code. So first of all, this hash was something new because set and multi-set were not implemented as hash tables. So let's see a small example just demonstrating how std hash works. So it can be interesting to you, so you can explore more on it. So first let's see the hash function. So let's say we have size t, h1, and then std hash. So we have already using std, and also you need to include the functional. And the key that we want to provide would be of string, and then empty body, and then let's say hello. And next, world. And now let's print the hash values. So these are the hash values of hello and world. So if you change it, small h, it should change. Now let's, you can directly also print it. You don't need to create objects of these. Hash int 100. And next we will create a float 100.5. So for the case of int, it does not need to calculate hash, it can return the int itself. So for 100 it returns 100, and for 100.5 it returns this hash value, and it will map different things to buckets, the number of buckets in the hash table, and there is a load factor in hashing. So let's comment it for now. This is not the part of our main discussion on unordered set. So now we will see the unordered set. First we will see on int type or any other primitive type, and then we will move to our custom class. So make sure to include unordered set. Then let's insert 5, 10, or it's int, we can give int So this is not a set or multi-set. So here ordering is lost. This is not a binary search tree, it's a hash table. So let's see, here it will not be in the any order. It can be large value followed by small value. You see here 20 is the largest, 20 followed by 15, then 4 is the smallest, then we have a larger value. So you can see clearly that there is no ordering defined here. So this is the difference, and the same behavior we will see in unordered multi-set. Now let's, for the sake of completeness, let's use all of these functions, although we have already seen examples of these in our earlier lessons. This is size, then let's see an example of count. So we know that 5 is occurring 3 times, but it will be inserted just once, so it will be either 0 or 1. So in this case it should be 1. Next, let's say we want to erase something. We erased 5. So it should return 1. So we will check whether it's, we will try to use the find and we will compare it with end. So that's why I am using bool alpha, so that it prints true or false in the string format. So us dot find, what number we can find which is not present here. So let's say 16. 16 is not present. So it should be equal to us dot end. So if it's present, it should not be equal to us dot end. And let's run it. So size is 5, count of 5 is 1. If we erase 5, it's 1 because 5 was present. Then found 16 is false. So 16 is not present, so this will return us dot end. Now let's also see that load factor and number of buckets. It's bucket count. And then load factor. So what are number of buckets and load factor? So when we are implementing a hash table, so you see load factor is 0.36 and number of buckets is 11. So when we implement a hash function, we have, let's say, any object or a string obj1, obj2. So it will pass through our hash function and it will give one integral value, what we had seen here. When we had calculated the hash of this string, we had got a long integral value. So this is what is happening. So it calculates the hash function. This is our hash function, some integer value, very large value. This will also map to the same hash function and it will give another value. Let's say h1, h2. These are integral values. So we have some buckets. Let's say we have 100 buckets. But these values are very large. We cannot have so much, wasting so much memory by keeping a bucket for all of those values in the range of values that this hash function produces. So we keep a smaller bucket, smaller table. So we map it to this range. So its index will be from 0 to 99 if we have 100 buckets. So you can simply take modulo on h1 modulo 100. So it will return a value between 0 and 99. So whatever value, let's say it returns 47. So you put this object 1 here. Then object 2, h2 modulo 100 gives you 25. So you put object 2 here. And if you do multiple insertions, let's say thousands of objects you insert and your bucket size is still 100. So on average, if it distributes properly, each bucket will have 10 objects in it. So it's not a constant time. It will depend on number of elements per bucket. So we see that when the number of insertions increases compared to the bucket size, we create a new bucket, a new table with larger number of buckets, and then rehash. So a load factor denotes that on average each bucket contains how many elements. So let's say we have 1000 buckets and we have inserted 200 keys. 1000 buckets, 200 keys. So per bucket 0.2 key. So this is denoted by load factor. So we generally keep it below some threshold, maybe 0.75. If it crosses 0.75, it's time to rehash and create a new hash table. So these operations are constant on average, not every time. And bucket count denotes the actual number of buckets. So here we got number of buckets 11 and load factor 0.36. So you can explore more on these bucket related APIs. We will stop here and then now we will do the same thing on our custom class. So let's define a class. We will call it student, just like our earlier examples. And let's make everything public, although it's not recommended. It's just for simplicity of our code. So first let's keep it this much only. Then we will see that if we try to insert a student into an unordered set, it will give error because it does not know how to do hashing and also how to compare for equal. You can see here hash and key equal. So these are standard values, not valid for our class. Unordered set of students, USS. Same example. So we had taken some student named Simon in the last class and its ID was 50. And then we had taken 20 and its ID, its name was Thomas. So just run here and it should throw an error. So you see we get error. Now in order to fix that, we need to define our hash function. So first define the equality operator. So we will pass a const student s, and this will be compared against the current instance, this student, whether they are same or not. So there are just two attributes, ID and name. So if both matches, we will say that they are same. So we will return s.id and this name is equal to s dot name. If both are same, we will say that these are same. Let's also define the print student, just like we did in our earlier lessons. Now we will define the hash function. So we need to define one operator, which will be this parenthesis operator. So we have to define our hash function. So how we can define it? You can create your own custom hash function, or depending on your requirement. But in this case, I will just use the inbuilt std hash for int and string, and then add them. This may not be a good hash function, but let's just do it. Now we have defined our hash function and also the equality operator. So we need to pass this hash function here, student, and then now let's see if it compiles or not. So it still gives error. Operator is a private member, okay, so we have to make it public. And now it compiles, so everything is correct. So let's print the students. And let's see. So it prints both the students, and this ordering is again not guaranteed. If you have, you can try inserting many more, and you will see that there is no ordering between them. So I hope you understood the different functions of unordered set and how to use them and how it internally works. With more practice, you should get more familiarity with its APIs.